Hello, I'm Abhinay Adi. This is a continuation of my final project PPT and of the part 5. In the part 5, we can see here that the proposal and in the part 5, we have to describe the improved convolutional neural network performance. And in this proposal, the pictures in the database are 32 by 32 pixels in size. Machines would find it simpler to process images with fewer pixels than those with many. Some techniques that may be utilized to enhance the performance by initially deleting a small number of data samples from a variety of heavily sampled data classes. So here we have to eliminate small data samples from a larger sample classes so the performance can be improved and we can obtain the improvements in the neural net CNN. It is feasible to improve the model by using the data from a subset. The weights assigned to each class are listed. Each class will be given the same value during training if class weights are utilized to train on a very unbalanced or biased database. So it's not same for everyone. The trained data, which are the following, I used to modify the model. And in the next slide, we can see the result. After a pooling layer and an additional convolutional layer new are added, the accuracy increased to 73.8%. And this we can see in the image of the accuracy is given, can be seen in the image. So the accuracy is increased to 73.8%. So in this part 5, we have the performance has been improved and we can see it in here. And in the next slide, it's a report one. The third convolutional layer processes the data and resizes it to 4 into 4 by 128. The output of the second pooling layer from part 3 is then fed into this layer. And in next, the third pooling layer will be flattened and the data into a 4 into 4 into 128 into 1024 array. So, and the output from the third convolutional layer as input. And in the next slide, the third pooling layer will be flatten the data into a 4 into 4 into 128 into 1024 array to 1024 into 1024 pixels. The data will be scaled in this. We can observe the data has been scaling from the pooling layers. And in the next, the first fully connected neural network, the FC1, receives the flattened input by activating the array. Yeah, and from in the next slide, yeah, here it is. The second fully connected neural network, FC2, receives the output from FC1. It will be removed from this layer to get to get precise output with 10 nodes for each of the 10 categories. A random propagation of the outputs are deleted. So we have to eliminate few of the random proportions of this. So we can attain the improvement in the neural network, the convolutional neural network. And in the next one, a 50% chance of maintaining the dropout is included into the model during training. And in other words, we can say that a random selection will be made from the remaining 50%. So the 50% is going to be dropped and we can randomly select from the remaining 50. So, and the model moves up to 5,000 steps. You can see here. And in the next, when we go to the next slide, after training, the model's accuracy is tested over 100 steps. So in this process, we're gonna test for every 100 steps, we're gonna test the accuracy of the model. After when we complete the training, we're gonna test it. We test the accuracy. As of the 50th step, the model's accuracy was 73.8. As we mentioned in the earlier slide, in here, the accuracy of this one is 73.8%, as we can see in this image too. And when get back to the slide, yeah. As of 5,000 step, the model's accuracy was 73.8. And it can be seen from here, the accuracy increased once the CNN model from part 3 was modified. So if the part 3 was modified, we can see the accuracy has been increased to 73.8% at the 50th step. And we can, if we go to the next slide, there's a project report slide. A neural network type known as convolutional neural network and can be called as short form as CNN, is particularly adept at processing data, having a grid-like design, like an image. We can say like that, it's kind of image. And digital pictures are binary representation of visual data. Pixel values, which specify how bright and what hue each pixel should appear, are rearranged in a grid-like pattern. Okay, is this, and this can be, the grid-like pattern is very useful in this. And in next one, each of the 10 classes in the Cipher 10 collections has 6,032 into 32 color pictures, and 10,000 photographs serve as testing images, and 50,000 serve as training images. So we can see in this Cipher collection, the 50,000 training images, 10,000 photographs, and 6,032 into 32 color pictures. And in the next one, yeah, 5 training sub-data sets and 1 test sub-data set are created for each of the data sets, consisting of 10,000 photos. And 1,000 random photos from each class are included in the test subset. The remaining photos, which are not selected, not included, are arranged in the training sub-data sets in a random order. So after selecting the 1,000 photos from the 10,000 photos of the data sets, the remaining are arranged in a subset in a random order. So they can be arranged anywhere. But certain sub-data sets may have greater number of images from a particular class than others. There are precisely 5,000 photos from each class in each training data set. And here, the few of the subsets contains more number of images which are belong to only one class, and 5,000 photos are present in each class of the training data set. And when we move on to the next slide, yeah, in this next slide of the project report, mutual exclusion exists between the two groups. So they're gonna exist between two groups, There are differences between cars and trucks. In the category of automobiles are cars, SUVs, and similar vehicle as trucks, only big trucks are included. Pickup trucks aren't part of the either. So in the automobiles, we can see there are cars, SUVs, and sedan, and similar vehicles like sedans, hatchbacks are considered. Whereas trucks are only the big trucks are included. Pickup trucks are not being included in this. And in the next one, the project's objective is to utilize the CNN model, that's convolutional neural network model, to process each of the several classes of images in the Cipher 10 dataset. The main motivation in this to utilize CNN model to operate the several classes of images in this dataset. And when we move on to the next slide, yeah, in this slide, we're gonna describe about what the student has done in the project in all three parts, the part 3, part 4, and part 5. And here I'm going to explain what I have learned in this project from all these 3, 4, 5 parts. And in from the part 3, the im the point is that the image data is ready to be fed into the first convolutional layer after being collected together with the Cipher 10 dataset. And in the next one, the next two convolutional layers, two pooling layers, and two fully connected layers transfer the data. You can understand all these convolutional layers, pooling layers, and fully connected layers from the neural network diagram or the image. We can see it here in the 9 part 3 slide, and this is the image we can get. We can have the idea about the convolutional neural network. This is a fully connected one, and when we get back to slide, the next two convolutional layers, the two pooling layers and two fully connected layers transfer the data in this neural network from the data set. And then 10 node output is then obtained by discarding a portion of the output. So that output can be achieved by we have to eliminate or discard a few portion of the outputs. So then we can ultimately get an 10 node output. And we then next move on to our next slide. In this, the dropout is kept in the middle with a 50% chance throughout training. That is, a random selection will be made to remove the remaining 50%. So we can select randomly in the training so that the remaining 50% can be removed, and the model walks 50,000 steps. Sorry, it's 5,000 steps. And the model is trained and its accuracy is tested every 100 steps. We have seen this earlier. For every 1,000 steps, we have to check the accuracy of the model, and the models will walk up to the maximum of 5,000 steps. And when we go to the next slide, yeah, and at the end of 5,000 step, how accurate is the model? I have found that how accurate is this model. I've mentioned the accuracy in the earlier slides. At the end of the 50th step, this is what I learned from the part 3 in this project. And moving on to part 4, and and in this we can see that on the min data dataset, which contains of 60,000 black and white handwritten digital images, a comparable convolutional neural network model from part 3 is used. So the model CNN model from the part 3 is used in the part 4, and the accuracy of each step is examined on the cipher dataset from part 3, the MINIST dataset from the assignment 4. So in this part 3, in the part 4, I have learned the accuracy step is examined from part 3 and MINIST data from part 4. And here we can see uh, we have mentioned it in the document, the Word document. And in the next slide, in after part 4, the accuracy of each step is examined on the cipher then dataset from part 3 and the MINIST dataset from part assignment 4. And here in the next slide, and due to the picture dependencies such as pixel size, color, the MINIST data set is more precise than the cipher 10 data set. And you can see here the picture dependence due to picture dependencies such as pixels and colors, the cipher data set is not as precise as the MINIST data set because of the pixel size and color. This is what I learned in part 4 of this project, and we have compared the cipher data set and MINIST data set in the part 4. And when we move on to part 5, the model from part 3 has been modified to incorporate 3 convolutional layers, 3 pooling layers, and 2 fully connected layers in order to improve performance. So we have, if you want to improve the performance, we have to modify the convolutional layers, the pooling layers, and also the connected layers so that we can achieve the performance and in the convolutional neural network. And this model is built, trained, and tested using same process as in part 3. So in this part 5, we use the same build, trained, and testing process as we used in the part 3. So we can see here in part 5, here the accuracy is 73.87, and in this we can see the accuracy is 70% as a result of the model accuracy. And when we get back to our slide again, yeah, the model from part 3 has been modified to incorporate the 3 convolution layers, 3 pooling layers, and 2 fully connected layers. And this has been, all these models should follow the same process as it follow in the part 3, as I shown the accuracy there. And this is also has been done in the part 5 to improve the accuracy, improve the performance, and we have achieved it. And the following testing, the model precision increased to 73.8. In the part, when we see in part 3, the accuracy is 70%. And, and after these all the modifications, we can see in this, the performance increased to 73.8. And this is all we learned in part 5 of this project. And the following testing, the model's precision increases to 73%. So we can see the increase here up to the 73%, 73.8%. And in the next slide, the conclusion from the part 3, 4, and 5. With 70% accuracy, a CNN model that consists of 2 convolutional layers, 2 pooling layers, and two fully connected layers can access 6,000 color images with 32 into 32 pixels. The computer can more accurately predict the following if predict the images when extra layers are added to the CNN model from part 3. Despite using the same model for both colored and black and white photographs, the machine is more accurate when analyzing black and white photos than color. So we can see the black and white colors, we can analyze it better, and the machine is more accurate when we use the black and white photos. When extra layers are added to CNN model from part 3, it can the predict images more accurately. And this is this is a conclusion from part 3, 4, and 5. And I have learned a lot of knowledge in this subject. Thank you everyone. This is Abhinay Adi. Thank you so much.